Hi, my name is Jennifer. I'm a first year in Weld, and I'll be in Elliott next year. And I'm concentrating in physics, so here is my CS project, the physics simulator. Here's the home page, and you can see that we have 3 different simulations, which you can access on the top here. Let's start off with the pendulum. So for the pendulum simulator, we'll have to specify 2 initial conditions, the angle at which you throw it, so let's say 25 degrees, and then the length of the pendulum, so let's say it's 1 meter. So when we simulate it, we can see that the behavior of the pendulum is indeed what we expect. It's a sine function in terms of the angle with respect to time, and that's true because it's just a simple harmonic oscillator. And so next, let's look at the projectile. So for the projectile, we'll have to specify 3 conditions. The first one is the speed at which I throw it at. Say that it's 35 meters per second. Second one is the angle, we'll say 1 degree or something. And the third one is air resistance. So we'll put like 3.5. And so when we simulate it, we can see the behavior of this projectile is indeed what we think it should be. From throwing a baseball, for example, we can see it goes through the air and it slows down at the end because of air resistance. And finally, let's look at the quantum simulator. So this one simulates a quantum point defect, and we can say that there are 6 different energy levels, and we have a bunch of, we can say electrons, for example, that can move through these 6 different levels. And the rate and whichever level they're allowed to move through is governed by quantum mechanics. And in this simulation, I used a rates matrix in order to solve for these different populations as they go through time. And so we can specify the population of the first 3 states. So let's say 3, 6, 2, and these can be electrons or whatever you're looking at. And so when we simulate it, we can see that the population of all of these 6 states plus a 7th intersystem crossing state evolving with time, so as some decrease, the other increase. And basically how these are all like plotted is using a 2D array. So I solve a first order differential equation with 2D arrays and a rate matrix using a dot product and exponential matrix function, and then I pass that in so that it makes this picture, and then that picture is passed to the front end, and then it's then displayed.